Hi everyone, welcome to Analyst Spot. My name is B. Mohammed Swaib and I will be explaining you how to do EDA, Exploratory Data Analysis on Sample Superstore data or in retail business data. Here, the task is to perform EDA on Sample Superstore dataset. I have uploaded here in SampleSuperstore.csv file in my GitHub account analyst spot. You can go and download from there. And task as a business manager, try to find out weak areas where you can work to make more profit. Explore all business problems you can derive by the data. Then there is a Tableau storyboard. If you go to first link, it will directly go to the Tableau public link, so you can play around here too. Here it will be a easier way how you can play around with this sales discount, different entities I have created here, category, orders, calendar, everything is provided here. You can go to the Tableau and you can play around with my Tableau storyboard. Do follow me on Tableau too, and do fork this repository so that you can get the regular updates on this. So now let us dive into the coding part now. Okay, now I'm putting warnings to filter out the warnings in any of the coding part. I have and importing the pandas, matplotlib and cbon libraries. I'm importing sample superstore.csv dataset here and printing the top 10 rows. As you can see, there is 0 to 9 a row here, shipment mode and everything from dataset, and I am printing final 10 rows here. You can see it here. First, let me find out what is the shape of the dataset. We have 13 columns and 9994 rows in the dataset. As you can see, the last index is 9993. That means it starts from 0 and ends with 9993, so that we get 9994 rows. Next, let us find out all the column names. So there are 13 column names here: ship mode, segment, country, city, state, postal code, region, category, subcategory, sales, quantity, discount and profit. Now let us get the summary of the dataset. By using df.info function, you get the summary of the data frame. You can see there are 9994 rows in all the columns. The count of the null values is 0 here, so there are no null values here. Then you can see the data types. There are object, integer and floating data types. So you can also get the summary as there are 3 floating point columns and there are 2 integer columns and 8 object columns here. The memory used by this dataset is around 1.1 MB. So when I use df.isNull.sum.sum, we get 0. So there are not even a single missing values. That is good. That is good. Let us find out the total number of null values in each columns. So you can see there are 13 columns. In the 13 there are not even a single null value. So that is great. So let us go next. The statistical details. The statistical details gives count, mean, standard deviation, minimum 25th percentile, 50th percentile, 75th percentile, and maximum value in the columns postal code, sales, quantity, discount, profit. df.describe function works on only integer floating point columns. As you have seen here, there are 3 plus 2. There are 5 columns which are integer and floating point columns. So you can see postal code, sales, quantity, discount, profit. There are 5 columns here which are integer and floating columns. I have given an exemplar image here. You can go through this. See, for the series 2, 3, 4, there are 3 numbers. So the count is 3. The is mean or average of these 3 values, and standard deviation minimum of the value is 2 here. Maximum is 4, and we get 25th percentile, 30th, 50th percentile, and 50th percentile and 75th percentiles. Okay, as we have seen in df.info function, we can also get data types of each and every column by using df.d types. You can see postal code is integer, sales quantity. You can see postal code, sales quantity, discount, and profit. These are the 5 columns which are integer or floating. Then other all are objects, you can see. Now let us check the dataset for duplicate values, and let us drop these duplicate elements. Here you can see by using this duplicated function, we get 17 duplicate values in the dataset. That means 17 repeating elements. So we are dropping the duplicates in the next step. Now let us see what are the unique values, number of unique values in the each column. So df.nUnique function gives the unique values here, number of unique values here. The shipment mode column contains 4 unique values. Segment column contains 3 unique values, and so on here. Now next let us go to the correlation part. I have given a image on what is correlation here. Correlation is a number between -1 to 1 and tells us how well a regression line fits the data, and defined by this equation. Here you can see if it is a perfect positive correlation, that means it will be 1. The correlation is going upwards. For negative 1, it is coming downwards. For 0, that is no correlation. It means the data points are scattered around, and they don't have perfect positive or negative correlation. So we get for df dot correlation these values here. We get negative values, plus values, and 0 point values here too. Now let us find covariance. Here I have given the image on how covariance looks like. This is also similar to variance. You can see largely positive, largely negative, and 0 covariance. Now let us see the series containing the number of unique values. In df dot value counts function gives the unique values in the each column. So it is scrambled here, but let me explain. Shipment mode, segment, country, city, state, these are all are different columns. Here also subcategory, sales, quantity, discount, profit. They should be straight in the straight line, but due to the constraint, space constraint, it is printing it down. In shipment mode, there are standard class, second class, and so on. Like that, there are different values for each and every column. You can see here postal code has many variance values, 9,000, 6,000, and so on. As I have mentioned, postal code has many variable values. So let us drop that column and create a new data frame here, df1. From now onwards, let us go to the visualization part of the dataset. Here we are plotting the graph of category and subcategory here. The down mentioned are the subcategories here. These are the categories here. Let us go to different subcategories. Under that, let us do the visualization. You can see by the visualization the count of how many items are there in subcategories for bookcases, chairs, labels, etc. and so on. Binders as highest, and here you can see this is the lowest one. Next, let us draw a heat map on correlation values. So we are plotting the heat map for the correlation of only these integer and floating pointed columns. Here you can see for discount and profit the correlation is least. Now let us go to the covariance part. You can see this is a heat map for covariance. Next, let us go and plot the visualization for segment part. For different, there are three segments here. You might have seen that consumer, corporate, and home office. There are three segments here. There are 5,191 consumers and 3,000 corporate, 1,000 home office segments. I have plotted it here using count plot. Next, let us plot bar plot for subcategory and profit. Let me show it here. Bar plot for profit versus subcategories that are books, chairs, and so on. Let us go to the coding. Okay. Now let me plot line plot for discount versus profit. If discount is 10%, then the profit is more. If the discount is more than 15%, then there is a loss for the organization. So it is better to keep less than 15%. Next, let us go to histograms. Let me plot histogram for DF1. You might have noticed that I have removed one column, postal code, since it is a variable. For 50 bins, let me create a histogram plot for sales, quantity, discount, profit. Since I have removed profit, there are only four integer or floating point values in the data set now. So this is a histogram for four different values. So next, let me plot pair plot for subcategory. You get sales, quantity, discount, and profit, how they are related to each other. So you can go through this visualization too. Next, let us group or sum the sales, profit, discount, quantity according to every state of region and also according to subcategory sales. Then the data set looks like this. You can see here shipment mode, segment, categories, subcategories. These four are grouped according to the state and region. Others are integer and floating point columns. We are grouping according to state and region here. Next, let us use group by function to group states with respect to profit and get count, sum, minimum, maximum, mean, median, standard deviation, and variance. For different states, we can see different values. Next, we are using k-means clustering algorithms to categorize the subcategory in the dataset. You can see here I have used Seaborn facet grid to categorize subcategory with respect to sales and quantity here, and I have used a scatter plot here for different subcategories. Next, let us go and plot pair plot for DF1. For DF1, we have four integer and floating point columns. Next, we are plotting subplots for sales. Let me open it in the new tab here. Here you can see I have created a bar plot here for different values of sales. You can see more than 20,000 there are only one sales. More than 15,000 there are only one sale. There are only two sales here. Next, let us go and plot a box plot for discount. Here you can see how the discount is varying with respect to box plot. You can see the outliers here for 60%, 70%, and 80%. These three are the outliers here. Next, let us plot a subplot for profit 2. So you can see here there is only one above 8,000 profit and two above 6,000 profit, and also there is one below 6,000 loss. Here you can visualize it. Next, let us find out IQR, interquartile range. Let me explain this. Interquartile range is range between quartile 1 and quartile 3, Q1 and Q3 here. These middle values represent interquartile range. Okay, coming to the coding, first quartile is under 25% and about 75% is the quartile third. So we are getting it here through Q1 and Q3. And Q3 minus Q1 gives interquartile range. You can see here postal code in between is 66,785, sales is 192, and so on. We are only plotting IQR for integer and floating point values here. Next, let us plot a bar graph for dataset values. You can see here there are different column names: ship mode, segment, country, and others. 13 columns here. So we are checking different for different value how the bar plot works here. Next, let us go and plot the scatter plot for sales and profit. The profit is more when the sale is more than 15,000 and less than 20,000. There is a loss of 2,000 for more than 20,000 sales. So the business manager can keep more than 5,000 and less than 20,000 accordingly as per his plan. Next, let us plot a distribution plot here. You can see I have plotted a distribution plot for sales here and for bins 100 bins. Let me show it in the new tab here. The density of the points is more between 0 and 5,000. That is, previously you might have seen sales and profit. The density of the points are more here. That is mentioned in the distribution plot here. So this is a exploratory data analysis which I have created on retail. I have given the link of my code and CSV file in the GitHub account analyst spot. You can go to my GitHub account and you can download it and use it here from here. I have also provided the Tableau public dashboard or storyboard link. Do comment below for any queries or updation. I will also create a video on data science and analytics. Do check them out. Thank you and see you in the next video.